all right? Including me.
I
Go
was
ahead.
doing exercises like inside of the model for normal distribution, and I couldn't find the answers for page 7 and 8. And it's just for me, like, to make sure that I did them correctly. So I don't know if like there's enough time to go through them, but if not, to see if you can share those answers with us so we can make sure that we have them and compare if I did something wrong. Because
Okay, perfect. Listen, I just want to mention about the quiz today. I mixed together normal and regression. I don't know if you guys saw it, if it's visible.
It shows like it's from 11 to 11:20.
Oh, let
It's
me-
showing NOR and RLS.
Okay, so that you know it's going to be on that. And so we will focus on that, and then we can go into other material as well, right? Um, like I said, for the other quiz, it will be your grade will be out of 4. So you got your grades. I don't hear anybody, everybody got their grades. You can see your points, and it's even going to go higher because I'm grading out of 4 or 5. I think maybe I'll grade this one out of 5 because you guys are getting stronger. So giving you guys a little bit of a boost to continue, not to be discouraged. Okay, so wait, let me open the platform to look at what I think I know which pages you're talking about. Let me open it.
Yeah, it's 7 and 8, and then you in one of the videos you solve uh for the exercise that it's on 6, and you gave us an answer that it was supposed to be 95.5, but I get 97.3. So I don't know if I did something
Okay, we'll
wrong
talk
or
we'll
not.
talk about that too. Yeah. Okay, let me yeah, we'll do it all. I'm doing in English. We are recording, right? Yeah, we're recording. And now give me the page number again.
So the one, I don't know why it gave me 97.35. It's page 6, exercise 3. The
Okay.
probability of X being greater than 60. When I solved it, it gave me 97.35. But then the answer that you gave on the video was 97.5. So I don't know if
Okay, let me
I missed something.
okay, hold on. Let me do it for you.
Thank you.
I should give points for students who find errors. I always say I'm gonna do it. I don't know if I put it in the prontuario yet. I'm pretty sure I
We
did
can
put
make
it.
it a rule now.
We can start now. If you find errors, that gives you incentive to give me feedback, and I presume you are reading everything carefully, but it gives you an incentive to tell me when I'm wrong. I'm just gonna grab my
And maybe you're not wrong and I just did something wrong because I noticed that I'm putting numbers incorrectly in the calculator. So maybe it's a me thing.
I have the same question on the same problem,
Okay.
so we're
I'm
good.
probably wrong. I probably made a mistake, which is amazing that it's been there for so long. Okay, let's look at it. Um, so I'm gonna switch to my iPad. And gonna share my iPad, the same question, so everyone can write it down. PX greater than 60, and the information given is X is normal with a mean of it's 64.2. Mean 64 and standard deviation 2. Okay, let's see if I make any uh mistakes or if I do things differently, let me know. Okay, so we are going to standardize this. So we're asked to find the chance that a height, uh-oh, something happened. Are you there?
Yeah, but we cannot see the screen anymore.
Yeah, the connection broke. I don't know what happened. Do that again. Oh, my computer died. My iPad, uh, probably because I didn't charge it. So I'm going to do this a little different. That's the problem. See how much juice I can get out of it. Can you see now?
Yes, we can.
Sí, sí.
So you're going to standardize. When you standardize, it turns it to a Z. And to standardize, we use Z equals X minus mu over sigma. So 60 minus 64 over 2. This is mu. This is sigma. And you get Z greater than -4 over 2, which is -2. Is everybody okay with that?
Yep.
Ah, hold on. My iPad, I'm gonna have to do it another way. Unfortunately, it's always something that gets me. Gonna It's just that it's not charged. I always think I turn it off, but I don't. So I'm gonna plug it in and project. It might look a little different. Let me pause for a bit. I'm gonna share you my desktop. And you see the whole thing. You can't see each other, but you're gonna see my desktop. Okay. Can you guys see each other?
Yeah.
Oh, okay.
Yes,
So
we
Zoom.
can.
Okay, I can't see you, but okay. All right. So this is it. This is gonna work, I hope. So we standardize. Oh, I lost my work. That's weird. Okay, it didn't even record. So Z 60 minus 64 over 2, and we said that's -2. And -2 is going to put us over here 2 standard deviations before, and I already drew this out. So it's going to be 64 minus 4. So that's 60, right? And we want to go this way. And 2 standard deviations from the mean should be 95%. Do it this way. So I think you're right with what you did. And I don't know how no one told me before. So this is 95%. It's outside 95%, which means it's 2.5% on either side. Right? And to make 100, so if I want to go all of this way, I have to add 95% with 2.5%. Yeah, so that's 97.5%. That's the answer you like? That's what you got?
No, that was the answer given, but for some
Oh.
reason I'm getting 97.35.
Oh.
Um,
So 95 plus.
but I think it is because I was using the 99.7, which is the one that usually is between the three sigmas. And I just noticed
Oh, because
it.
this is okay. So 99.7 is with 3. This is only 2 standard deviations.
Yeah, that's what I think I did wrong. So
Okay,
this
good.
helped me clarify. So
Okay,
thank you.
good, good. And
Alice, you had the same answer. Was it the same case for you?
Yes, because I noticed the 2.5 math. Like I think what I missed, I did the same exercise because I thought that you grab more of the more than 95 because you go all the way to the other side. So that
yeah.
was misleading for me, same. Um,
Oh,
so it
okay.
was 95 plus something, and probably that was the miss, dividing that difference, that 5% between the two sides, and then add that. And
Yeah, yeah,
I think
Yeah,
that's the
that's
trick. But I
that's
did
yeah,
what
it
I missed.
but
wasn't that hard, but I lost. I was
but
in the same page.
did
Like
I explain it in the video like that or not?
No, you
no,
just left the answer for us to solve it. So
Oh,
that's why
oh.
we had the question. Because it
Okay.
said like, oh, you solved this, but the answer is gonna be this. So that's where I was like,
Okay.
I'm missing something. So, but thank you. This makes sense. It's just I was using the 95, the same case as Alice. So and then for the other exercises, which are in page 7 and 8, I looked for the answers in all of the pages that we have published in
Uh-huh.
Moodle, but I couldn't find them. So I don't know if I don't think we can. I don't know if we can cover all of them, but if not, can
Yeah,
you
so which
give us the
ones?
answer?
So let's see, let me stop for a minute just so I'm gonna look at so 6, 7, and 8. So 3. So you're okay with 4 or 5?
It was page 7 and 8. Like we don't have the answers for them.
For
I
any of
did
them?
them, but I don't know if I don't. I
Okay.
don't.
Okay, I'll do a few. I mean I could do them. Now remember this basically yeah, this you need to know how to do this for sure. This is standardization. So yeah, I think I can spend some time here. So let's see. So you want page so yeah, just page 7 and 8. Uh-huh. Okay.
Professor,
And I didn't put it in the videos. It's not in the videos of down here, 7, 8.
Not in the
no.
videos, nor in the like,
Oh, I
you
skipped
know,
it. I skipped it.
yeah,
Okay. Well,
yeah.
And
there's some gaps because I need you to test yourself. So yeah, no problem. Go
and
ahead.
Professor, you did mention in the video that there's some of those exercises that have a like a star by it, and then that you wanted us to try to go a little bit deeper into those. Like same with IRAM. I tried doing it, but I honestly don't know if they're
Okay,
okay
no
or not.
problem. Okay, so let me um let me copy them here and get to them. Is everybody okay with this? We're gonna spend, let's see, 5 minutes, 10 minutes. I'll do it as fast as possible. You get the hang of it. And see if I can keep my time under control. I'm just copying the questions on my iPad. Okay, the first 3 I can do all at once. Let's look at those. You see my screen?
We can.
yes.
Okay. So for x less than 70, standardize. And we standardize because we know the standard normal curve, right? So standardizing z is 70 minus 64 divided by 2. You guys can tell me what that is.
0.3.
0 point?
3.
But 6 divided by 3, just negative 3?
No, sorry, because
It's straight.
since
It's
It's
3.
yeah,
just straight.
yeah,
Yeah.
it's 3. Yeah.
Okay, 3. And then, okay, so I'm going to draw it here. Let me do that again. So we put 1 here, 2 here. Actually, I'm not doing a great job. Let me do that again because I made it too flat. So 1 is here, 2 is here, and 3 is here. And 1 is, so I always draw it, the first one, just where it starts to curl up. And I want to go to greater than 3. All right, so tell me the answer. If I'm going to go here, what's the answer?
97, 99.7
99.7 divided. Yeah.
So 99.7 is it in between?
plus, yep,
Yeah.
plus 0.015.
It's 0.15? 15%?
Exactly, 0.15. All right, so yeah, so you guys can make sure you have that result, sorry, nearby so that you can, get used to these numbers. But yeah, for 3 standard deviations, it's going to be this divided by 2, which is going to
Uh,
be
I have a
0.3.
question because it's saying x less than 70, so I have like the 1 minus 0.15, I guess.
Oh, I went the wrong way. Sorry, I changed the arrow here. Sorry, okay. Why did I change the arrow here and here? I don't know what happened. All right, so let's go the other way. Sorry. Less than 3.
70.
So what is it? Less than 3. So this is greater than 3, but I want the left side. So what do I do?
1 minus or 100.
Yeah, let's work with the 100 just because that's what I did
Yeah,
there. So 100 minus
exactly.
0.15,
0.15.
and you get? So the decimals will really throw you off, right? It's a small number because it was 0.7, it's 0.3 divided by 2 is 0.15. So but it's still 100 minus 0.15, which is
99.8.
99.85.
85. Yeah.
there you go. How's that?
Yeah, that's what I got in when I tried doing it.
Okay, so that if that's 99.85, what is this one? Number 5.
100?
15%.
0.15.
Yeah, 0.15% the other way.
Mm-hmm.
And then what is the next one? What is 6?
So, Professor, for me, what really got me there is that, greater than equal. That equal, I don't know if that had any effect on the problem itself.
So you have to remember at the beginning I explained for continuous distribution, there is no density. So what it looks like is it would be like x greater than 70 plus, and like you said, does this add anything? That's the question. But this is always 0. Okay? There's no
Okay,
density at a point. So that's how you put that together and you get the same answer.
awesome. I
Okay?
forgot that.
Yeah. That's what we're doing. We're just reinforcing. Okay, so then we know the answer for 8. What's the answer for 8? What's the answer for 8?
0, because you can have anything
No
equals
density
to, yeah.
at a
No
value,
density.
right? There's no density there. There's just no density there. There's no area. And then here, so in a way, you can think of it theoretically, there's no chance of being exactly at a point like 82, but it's only within a range of values do we calculate for continuous distributions. So here's a range of values, and to calculate within that range, we need to standardize again. Are you guys ready to go into number 7? So all those were related. So I took advantage and related these ones. So let's do this one here. So standardize. 62 minus 64 over 2. Z. 64 minus 64 over 2. And I get -1. G. And 0. Is that right? Now we draw a picture. I'm just going to copy the one I did here. What's the answer? I'll give you a minute. How's it going? So you want between -1 and 0. So you want this.
That's good. 9%?
It would be like 34%.
Right. So you can do this because I'm using usually the numbers you can go with the rule. You can just go with the rule. Or what I did was I calculate for both. I calculate the area from the left. -1 is how much? So I'll show you 2 ways, right? So less than -1 is how much? Well, this is between 68% up to here. So outside is going to be 1 minus, so 100 minus 68 divided by 2 is how much? So I'm
Point.
doing this because this is in between, this is outside. That's what we're doing. So sorry, say it.
0.34.
So it's going to be 34% outside, right? And then here, what's all to the left of 0? The whole area. That's everything.
50.
That's 50. And then I taught you to do the bigger one minus the smaller area to get to cut out the cookie cut this area out. That's what you want. So you take the big one, 50 minus 34, and you
I
get that
think
area.
the 34 is actually a 16 because it's 32 divided by 2.
Divided by 2. Thank you.
Yeah,
So it
exactly.
will be 16.
Okay,
I
good.
just got it visually because of since between the one of the segments and the 0,
Yeah,
we're supposed to have 68 between -1 and 1. I
that's
just divided
right.
it by
Very
2.
good. So then that's going to be 16.
16, yeah.
And what do you get?
The 34.
34 again.
Because it's 32, like in the 100 minus 68, that's 32, not 34. And then we need to divide it by 2, and that gives us the 16.
Thank you. So there's numbers floating around. So this is 32. You guys are correcting each other. You're correcting me. So that's 16. And so that's the long way to do it. And that's the way I want you to solve these problems when you don't know the values. But when you know the values, it's 68. What's half of 68, you said? 34. So you could have had the answer right away.
So I think that's what I did, Professor. So I did
And
this a
that's
long time
fine.
ago.
That's
I
fine.
did 68 between
Divided
2
by
and I
2.
got
Yeah,
34.
that's
Okay,
exactly.
perfect.
Yeah, that's
Okay,
good enough for me. You
okay.
if you use the rule, so what is the rule? 68, 95, 99.7%. That's the rule. And that's that's to one decimal place. But the tables give you more decimal places, so it's more precise. And when you have the tables, you use you go in the tables and you get the values and do the bigger minus smaller, okay, in general. And that'll give you more decimal places. And I also believe I taught you Excel, right, in the video? Did I teach you
Yes.
to use Excel? So that's
Yes.
also an option for studying for the test. You can use it for the test too, but you might not have enough time. I don't know. You can check with Excel if that's easier for you to. I leave it all open, all right? You can use any, as long as you understand. All right, so sorry for any confusion, but this is the one way to do it, 68 divided by 2. The second way is to use the method bigger minus smaller. It means you get the area to the left here, which is 100 minus 68, which is 32 divided by 2. There was some confusion because some people thought I was getting the final answer, 34, and they told me 34, and I wrote it wrong. But anyway, it's 32 divided by 2 is 16, which is this area here. And the other way is just, 68 divided by 2. All right, so you guys feel better about this stuff? There's some more problems. Let me go back and see the other problems. I'm going to get out of here if you want to take a screenshot or go to the video later. You can see it. There's some more problems. The star problems. All right. So let's talk about the star problems. Okay, so the discussion becomes, what if I give you a question going backwards? The backward type problem. How do I solve the backward problem? So this is instead of me giving you the value of X and asking for the probability, I give you the probability and I ask you for the X. Can you solve it using the rules that we know? So you should go back through your notes and see when you saw this number before. We actually, that was the first one we did, I think. Was 97.5. So if you draw that, so give you a second to draw that and I'll talk about it and then we'll do the others. Ready?
Yep.
All right, so this is the drawing. So where do I put the x? So this is backwards. I give you a probability and you have to draw it with the x. Where would the x go here? To have on the left of it 97.5. If I was here, the left would be 50. So I need to go a little more here, right? So somewhere around here, let's say. How's that logic?
Yep.
So this is my x, which I want to find. And there's 97.5 here. Which value of x would put me with 975 here? Now, if it's the x drawing, so this is what I get into. So this is x. If I put x there, I'm saying this is the x with a normal of mu of 64 and standard deviation of 62. I mean 2. Which feels a little, well, you guys can do it because we drew it so many times. This is going to mark, remember, this is going to mark 2 standard deviations, right? 95 and 2.5. I'll do it in a different color. So this is 2.5 and this is 95 and that makes 97.5. Everyone agrees?
Yes.
And what number is going to give me that? It's going to be 64 plus 4,
Was
4 or like 64 plus 2 times the standard deviation, right? So it's 2 standard deviations away. So you should feel unusual. You should feel uncomfortable doing that. That's the whole point of this exercise, is to make you think there's got to be a better way to do this than guessing, right? So it's 64 is in the middle. This is 66 and this is 68. So I found the answer because I know I'm familiar with this distribution. I've been working with it for a while. You've seen a few problems. So this will tell you to the left of this is 68. But my argument is there's a better way to do problems like this. And that's when I show you, I introduce the table. That's when I introduce the table. I'm working with the table. So that's all that was for. Questions about this? So you don't have to do this anymore. Basically, if this feels uncomfortable, don't worry about it because you don't have to do it anymore. You're going to use the table.
Okay.
You're going to standardize and you're going to go to the table or you're going to use Excel. Always remember the table always gives you the left side and Excel always gives you the left side. So if you want something going the other way, you have to do a 1 minus calculation. Keep that in mind.
Perfect. Thank you. I'll stick to the tables.
Yeah, so if it's that was the argument. Just if you feel uncomfortable, stick to the tables. All right. So then this other one here, again, this is like if you feel uncomfortable doing this because the numbers are not precisely the ones that we recognize, right? As 68, 95, as the ones that we've been working with, 58, 60, 62, 64, 66, 2 standard deviations is putting large or major tick marks on the normal distribution to help us. These are not those numbers. 55 and 65 are off. So we could guess, but no, just go to the tables and answer the question. So you guys do that with the table. Are you guys okay for 9 and 10? That's the argument that I make there. And
Okay.
then for number 11, you should also again feel like you know the answer. What is the answer, but uncomfortable about it because it doesn't seem that easy. So the question is find the values between which 68% of the observations will rest. So what is your instinctual answer for that?
Well, that's actually given in page 6. It's 62 and 66.
So that is the answer, but there's more answers. So let me show you what I mean. That's one answer.
60 to 66.
Just let me draw. All right, going back to my iPad. Okay, so here, right? So we're going to work on this one. What is the issue? The issue is one standard deviation would be 60 from 62 to 66 would be 68%. But that's not the only two numbers that you're going to have 68%. So let me show you what I'm talking about. So yeah, okay, so within one standard deviation, this is 68%, this is 64, this is 62, 66. So 62 and 66, so between 62 and 66 are 68% of the observations. But notice I said X1 and X2. That means the numbers, it's just kind of saying that you can have other answers. You can have other answers. What if maybe there's an area like this one? This could be so a little bit more that way. And then, maybe that's 68%. Like, I don't know. Like there could be multiple answers with 68% between. The point again is that to solve it, you want to use the standard normal table, and you probably need another piece of information to narrow it down to where you exactly are. Okay? Like there's all sorts of areas where, like, so this is here 30 or 16% we talked about, right? So this is 16%. This is 16%. Like there's areas in different places that aren't exactly your key ones that you can find the percentages that you're looking for. So we got to be very clear. Here, there's one answer if you're just talking about them being the one standard deviation away, but there's multiple answers. So this would be, the answer to this would be indeterminate or unknown or too many, there's infinite possibilities where you're going to find 68% between, basically. So that was just to make the point that you recognize the 68% as one standard deviation away, but there's infinitely many intervals that you have 68% between. And I'm trying to make that point anyway. Hope it landed. Here is the last one. Okay, any questions about that? Don't worry about that too much. Just trying to say, don't the numbers 68, 95, and 99.7% are a start. Then we introduce the table where you have so many different starting points or different deviations from the mean that you want to understand the area between. So there's so many different possibilities. And you have Excel, you have infinite answers that you can find where any interval falls. Then I go to number 12. Number 12 is just to show you that this is off our 68, 95, 99.7%. What is the answer for this one, in fact? Let me draw that one as well. You see my iPad?
Yes.
So where is 40? So, oh, I went the wrong way. Let me do that again. So 64 is here. Then we say 62, 60, 58. So all the way back here is like 40 over here. And I want to know greater than 40. What's the chance of being greater than 40? Is it greater than 40?
99.9999, close to 1.
Greater than 40. Sorry. So the point is that it's not on the chart. Anything off of the chart, I explained, we're going to say it's, yeah, we're going to say, okay, so this is the whole thing. This is like, you know, the whole, it's talking about the whole thing. And what's the whole thing? The whole thing is 100%. Or close to 1 is what I said. And you could even check it in Excel. In Excel, you could see so many decimal places you can observe there. And you'll see that it's like, yeah, 99.99999. It'll be very close to 1. So the table gives you 4 decimal places. So it's pretty much 100% because it'll be 99.99 at the closest one that you got. Remember the closest. So this is how many standard deviations away. It's way off the chart, remember? So 40 minus 64 over 2 is how many standard deviations?
Minus 12.
So it's way off the chart. So I've told you anything that's more than 3.47 or 3.5 outside, if it's going this way, it depends where you're going. If you're going this way, it's 100. If you're going the other way, it's 0. If you're going this way, it's 100. If you're going that way, it's 0. Okay? If you're outside more than 3.5 standard deviations away. All right, so that was the limits of the curve that I mentioned to you. That'll give you the answer. So, so that's that. So are you guys satisfied with that? Is that okay? That's how you deal with those. So it was just to stimulate and justify what we do next with the standard normal distribution. And that's what you're going to use from now on. Let me take this opportunity to talk about the quiz that I gave you to think about. So this quiz here, I asked you to think about these different situations and in your own life and whether these variables would demonstrate a normal distribution. Now, reflecting on what we just said, how would you answer? Forget about what you wrote. How would you answer that? How would you determine if a distribution was normal? What are you looking for? Well, I'm going to change the sharing to just here. So what are you looking for? So you guys did okay with kind of okay, but the main thing to talk about is the 68, 95, 99.7% rule. Which of you or who mentioned it? Did any of you
I mean,
mention
like
it?
we look for the bell shape of the of the
You look for the 68, 95,
Yeah,
99.7. So you need to, so you guys,
the symmetry.
yeah, so not just symmetry, not just symmetry. We go beyond symmetry. So what you would need to do, and that's what you would have to explain to show me. So you guys got the idea of the symmetry, and you mostly got the idea that most of the observations had to be around a predictable expected value, and then some could be higher, some could be lower. That would display symmetric distribution. But to be normal, you have to verify. Remember, we did some verification, or I took a distribution when I was looking at when we did the standard deviation calculation, and I was going plus and minus 1 standard deviation, 2 standard deviation, and we were counting. I don't know if you remember that exercise. Let me see if I can go back to that. It was this exercise in module 3, and the standard deviation here.
So what's the best way for a woman over 40?
Oh, sorry. I have to only open in Brave. So this one here, just verifying that's what I did here. Okay. So when you take 1 standard deviation, you're finding how many observations should you find in 1 standard deviation if it's if it's normal? How many should you find? 68, right? 68%. All right, look at this data here. So this is for this exercise, if you guys remember this one. So here we have 1 standard deviation, 8.2 and 9 plus and minus 5.3 is 2.89 and 13.51. Now go back to the data. How many of the observations are 1 standard deviation away? Is 2 1 standard deviation away? No. Is 8? Yes. Is
Yes.
10? Yes. Is 16? No. Is 5? Yes. So that's 3 out of 5. What percentage is 3 out of 5? What's 3 out of 5? 3 divided by 5.
60%.
Okay,
60%.
so it's not exactly 68, but it's close. So then you go to 2 standard deviations and you check. In 2 standard deviations, how far will you get? You guys want to check that? So do 2 standard deviation of 8.2 and 5.35. You should have not all the observations, 95%. And there still should be some,
4
and
of the value out of 5.
4 of the values out of 5 will be 2 standard deviations. So what's 4 out of 5? Is it true though? Wait, did you check? You got to add and subtract. So you got to check it. So 8.2 plus and minus 2 times 5.31. So that's going to be 8.2 plus and minus 10.62. So I think in 2 standard deviations, so let me I don't really want to write it out. Can you guys verify? So make this 2 standard deviations from the mean. What are the limits of 2 standard deviations from the mean? It's negative something, and it's going to be 18 something or 19.
Negative 2.42, and the other one's gonna be 18.82.
Okay. All of the data falls between negative 2.4, and 18.8. Do you agree? All right. So that's 100% in two standard deviations from the mean. So the issue is this is not a normal distribution. Okay. This is not a normal distribution by the standard that we established, 68, 95, 90. That's how you verify. That's how you check. And to answer the question, back to the question I asked you, to properly answer the question, you needed to mention that. You needed to say, well, the average is pretty, steady, and sometimes it's higher and sometimes it's lower, and sometimes it's much higher and sometimes it's lower, and there's extreme values. And yes, I can observe, or I could verify that 68% of the observations are in one standard deviation, 95% are in two, and 99.7 are in three. I didn't expect you to collect the data. I expected you just to make the point. Did any of you make the point? Do you remember making the point? Okay, that's what distinguishes your answer from symmetric to making it normal. That's all you have to say. All right. So, again, that was just for practice, but I wanted to show you how you apply it in general to, numbers that you're used to seeing or numbers you're familiar with in your life. So um, so I kind of like that question. And I mean, I don't like that you guys got it wrong, but I like that I made the point now and you get it. I hope you get it. Do you get it? So you need to mention. So I'll just make a point here. Let me try to project now. Normally, I've charged my iPad.
Professor, I didn't explain it that way. My explanation was based on that because it says a very steady number, everything is going to be clustered in together, and it's not going to be distributed. And a single bell shape is unlikely. I said unlikely to be observed.
Yeah. If you don't have a bell shape, then you have, your answer is right. It's
Okay.
correct that, yeah, if you said that. But if you just showed it was symmetric, that was not enough. That would not be enough. Sorry. But good. So you guys can correct, I guess, I mean, I can make comments on that. I guess I could. So, for a distribution to be normal, needs to be symmetric. Single peak, because, that's symmetric, but that's not single peaked. Okay, that's multi-peak. So it needs to be symmetric. It has to have one peak, not two or three. And it has to, have that bell shape, but the bell shape in particular observes the 68, 95, 99.7% rule. Noting there must be.
Professor, if you're sharing, we cannot see your screen.
Oh, really? Let me do that again. There, okay, it worked. Got it? So for a distribution to be normal, it needs to be symmetric, but single peak. It can't be double peak. And it has to observe the rule with outliers. There should be 0.3% outliers. That's the point. So saying something like, in Christmas, I get a bonus, and that makes outliers for my salary. That would be like, that's how you would defend this being the pattern. You know what? I didn't expect you guys to get it right. I really wanted to make the point today. So I hope you appreciate that. So it's not just about symmetry. It's not just about single peak. It's about observing this rule and that there should be outliers. So so if you have 10,000, let's say you have 10,000 observations, how many outliers should there be?
$300.
Good. Very good. Good. So it's 0.3% outlier. So what you do with the numbers, you turn it into a decimal and you multiply. 1, 2, 3, 4. Is it 300 or 30?
It's 30.
Okay, good. But you had the right idea. All right. Okay, so if it's 1,000, it's 3 outliers. So if you took 1,000 observations, some should be outliers. Just giving you an idea. So say, yeah, so I get a bonus in at Christmas would create in your data set if you collected. I had a few years. I allowed you to. I suggested collecting data for a few years, right? So you could have 3, 4, 5, whatever outliers. Okay. Okay, more of your questions for me.
I had one more on the normal distribution, and that one is just because it was saying, page 16, exercise 2, it says that it was equal to 0, but from my understanding, it's supposed to be equal to 1. I don't know if I'm missing something again.
Yeah.
So I wanted to double check that
So
one. It's
which page?
16. And then it's number 2.
Uh-huh.
In the video, I don't remember which video it was, to be honest.
It's
It
okay.
was saying that it was supposed to be equal to 0, but since it's supposed to be bigger than 82, that would be Z greater than 9, so it wouldn't be 0, it would be 1. Because it's greater than. If it was less
No.
than
Well, if it was
minus,
if it's greater than 82, it should be 0, right? So okay, let me see. Let me make it here. It's all right, so we're going to standardize this. So Z, and then you did 82 minus 64 divided by 2 gives you 9. Sorry, that's what you said?
yes.
So with 9, so it's like the same thing as the 4 that we did before. So here's your standard normal, but 9 is like, I do make the point, I always want you to draw the Z. Do not draw like X, the distribution itself. Always, I teach you the standard normal, so you standardize and use Z. So where's 9? So this is 1, 2, 3, 4,
Way to
5,
the
6,
right.
7, 8, 9. And I want to go this way. Is there any area there?
Oh, okay. Now I see my error. And I have it draw it like that, so I don't know why I was
It's
questioning
okay.
it.
It's
I'm
okay.
sorry.
No, you're learning, and that's what's going to happen. You doubt yourself. It's okay. It's okay. You're going to build your confidence. And yeah, once you see all the problems, sure, but you can't possibly see all the problems. So you have to lean on what you've seen before. And I get, just by showing you before, now you understand it. So this is 9, and there's nothing here. There should be nothing here. Like I've shown it with some area, but really it should be,
Yeah, it should be
very
closer
little.
to 0.
Yeah, it should be closer.
So if it was less than 9, then that would be 1.
If it was that one, that's right. That would be
Okay, got it.
100%. And
Thank
this is
you.
0%. There's nothing there. Even though I'm drawing it, I'm not able to cut it off. Like it should be nothing there.
And
Basically
it's
nothing.
just funny because the question I have written down, it's wouldn't be one question, and then is it zero because 1 minus 0.99999 equals to 0.00. I'm so sorry.
Hopefully my video didn't confuse you, but okay. No, now that you get it, it's good. Okay. Any other questions? Normal. Were you able to do the other problems?
Yes.
So most of the problems I solved, I know there's some I didn't solve, right? Like the last ones. So, sorry. All right. So these ones. Did you see me solve these on the videos in the class? I think I solved them in the class. In the lectures. The lectures, you always have to do the lectures first. You go into the page by page after. Okay, you do the lectures first. If you saw me solving in Excel, then you must have seen me solve these ones. So this page 17, 18, 19, 20. You don't remember? Nobody remembers? Anybody remember? Because we can look at those.
Professor, I think in the page, the ones in the page 19, there is a video on those. But I don't remember that. I don't have any notes for page
No,
20.
me neither.
Yeah,
But you guys,
yeah.
but in the lecture
I think the
videos?
last one, yeah, the last one that was solved it was page 17. I have a note to check the results in page 18 and 19.
Okay, so let's see. So let's do that,
I
okay?
only have till 17 as well. I have 16,
Okay.
17.
Not 19, 18?
Nine, yeah, I do actually.
For
Yeah,
19, I
the
have two. The
yeah,
exercise one, I have that one. I don't have anything
yeah,
on page 20 or page 18.
yeah.
Okay. Okay, so you watch the videos. All right,
Yeah.
so like I said, the lecture videos, the ones called conferencia are the most important. Okay, so you watch those. You guys are sure. So let's do that
Yeah, I
then.
watch all of the videos.
Okay, good. So I know that's another advantage that, we're not meeting. You have time to watch all the videos too. Okay, so 19, you said I did it or not.
Yeah, I believe this exercise it's with the one that you actually open like this curse. Because I do remember seeing a couple of videos about Michael Jordan and Rebecca Lobo. But
Okay,
page 18, I don't have anything. And I have a note
okay.
saying that I need to check the answers, and same for page.
Well, the answers are here. I have all the
Yeah, the
steps.
page 3, I think.
Like I have all the steps, but do you want me to solve it step by step?
Oh,
The answers are there.
yeah, I see them now.
The answers are here. But
Okay.
what I can do is okay, so yeah, the answer is 4-3. Example 3 is not there. Okay, so let's do example 3. So the idea is first I go into this exercise to show you how we apply or work with the normal distribution in practice, right? So this is kind of in this exercise, looking at men as a group, looking at women as a group, how does Rebecca Lobo's height compare? So as a woman, she's shorter, but relative to other women, she has a 4.96 taller, 4.96 standard deviation taller height, which is much more than Michael Jordan's compared to his gender. So that was a discussion about how to use the standard normal distribution to make decisions about what's bigger, what's more. And here, I do the same thing with on page 20. I do the same thing with the scores. Okay, so you want to compare two students, but they wrote different exams. One wrote the SAT and one wrote the ACT. So who has the better score? How do we decide that? What do we do? Well, we use the same technique. Standardize. Standardize Eleanor 680 with her group average and standard deviation, and standardize Gerald with his group mean and standard deviation. And now we can compare them. So this is how we compare normal distribution outcomes when they have, when they have different shapes, not, well, different, yeah. They're still normal, but they have different parameters. Let's use that terminology. So what do you find? Who is the better student, Eleanor or Gerald?
I,
Eleanor.
Eleanor?
So how did you figure that out?
Solving by
So
Z.
like standardizing. So C is less than 1.8.
What did she get? How many? Oh, she's 1.8 and he's 1.5, right?
1.5, yes, yes.
So 1.8 is better than 1.5. And
Yep.
then here's the numbers, 1.8 and 1. Does anybody want me to calculate that for them, or you guys know what to do, right? It's 680, it's standardizing, minus the mean divided by the standard
Minus the mean
deviation,
dividend by
27.
100,
Okay.
yeah.
And then find the percentile. So what is the percentile?
0.9641 for Eleanor and 0.9332 to Gerald.
Yep.
Gerald.
Okay. So should I write that down? How many people want me to write that second one down?
Yes, please, if you don't
Yes.
mind.
Yeah, to practice at least. Yeah.
I really appreciate you guys speaking English. You can speak Spanish if you feel more comfortable. Don't be shy. I mean, I might ask you to say it again.
I mean, like at least it helps to study in English as well
Yeah,
because
that's what Alice had mentioned. Just
yeah,
leave
speaking
it
English
like that.
helps to understand because studying in Spanish and learning in English. Yeah.
Okay. Going back to my iPad. So we're going to standardize, and you're going to tell me if I take 1 point. Oops, I already standardized. All I
Yeah.
need to do is go to the table. So going to the table, 1.8 is here, and I want to go to the percentile. So I look up z equals 1.8, and what do you get on the table?
0.9641.
Is there anyone who needs me to show how to get the values on the table? Anyone, and you can tell me in the chat if that's what you want me to show. Okay, so nobody. Okay, that's good. And so this is 96.41%, and she's still going to be bigger. She's going to be higher. She's going to be greater than 96.41 because she's also greater than 1.8 standard deviations from the mean. So she's quite up there. And then Gerald is
Yellow is 1.5.
And what do you get on the table?
0.9332.
Okay.
There you go.
So then, of course, she's bigger, but now you have the percentile score. So that's all the table gives you. I'm gonna go on. I'm gonna grab the table. Let's see the tables. So here's the positive table, and we look up 1.8, 1.8, and just one decimal place, like 1.80. It's right here, 96.41. That's what we got that number, and then 1.5, 9332. For if anybody wanted to see that, that's how we do it. And I do describe this distribution on the videos and how it works. All right, so then the next one is a backwards problem. So what score would Gerald have to get to be 99th percentile? So right now Gerald is 93.32. So we want to know what score Gerald would have to get to be 99. So 99 would be 0.9999900. I use 4 decimal places because the table has 4 decimal places, and I begin with Z. So this is 2 steps, right? Step 1, I draw everything with Z because I have the table for it. So I'm going to draw everything with Z. I have to take the opposite step as well. I have to look inside the table for 0.9900. So that's what I'm going to do. I'm going to go to the table and look for 0.9900.
Yeah, then in the video, then I mean like the closest number to that percentile.
Exactly. So yeah, so this table is giving us two
Right.
decimal places, or 4 decimals, but in percent it's giving 2 decimal places. So we have to choose between them, and we can't just average the values because they're not the same. I'm going to do that at another point, but we can't do that because there's a curve and they're not exactly. One is 2.33, so this is 0, 1, 2, 3, and this one is 2.34 if you look. So going inside, I have to pick, and my rule is to pick the one that's closest, and that's just how we're going to use the table. It's 0.9901. So the answer is 2.33. What does 2.33 mean? It is the number of standard deviations you're away. So this is 2.33. Using 0.9901. And that was the first step. So that's how far we know we are away. But now we have to translate. We have to translate from Z back to X. So we have to do the opposite action. To find X, we have to multiply Z by sigma and add mu. That's the mathematics of it. So this is what I call unstandardized. This was standardized. This is unstandardized.
Standardized.
So I say it in words. I say Z standard deviations from the mean will give me X. That's my formula I'm going to use. So I'm going to use Z 2.33 standard deviations for Gerald R 6 from the mean for Gerald 18. That's the tricky part. You got to pick. This is for Gerald. And then you have your answer. What do you get?
$31.98. So it will be 32, because I don't know if the SAT
That's
goes
okay.
with decimals.
Yeah, 31.98 is fine. That's a
So both
score.
answers can be all right.
Yeah, like, because the question's going to be a lot of them multiple choice, or, I mean, you show me you know what you're doing, so that's good. 32.
32.
It depends what I want. If I want it in points or, decimals, you follow the instructions. If there's no instructions, you showed your work. So 31.98 or 32 approximately. That means approximately. All right. So this week you guys were actually supposed to do probability. Like last week, you were supposed to start probability, and we're still in normal. So anyway, I prepared a quiz. Do your best. I have normal questions. I have 2 normal questions, 2 regression questions, and 2 probability questions. And maybe we need to spend some time on regression. And then, like I said, I can make it out of 4. I can make it out of 4 rather than 6. So you can skip the probability questions, or you can try them and maybe they'll give you points if they're easy. Remember, you can't go backwards, right? It's in order, so you have to answer it as it goes. There's 2 regression, 2 normal, and 2 probability. Because this week you were supposed to start probability and at least do anyway, you should have done the probability rules. But if you didn't get that far, it's okay. It's okay. We're gonna pick up pace now that I'm here for you. Well, you guys can contact me outside of the class time to meet if you have time. That's only the problem. All right. You want to do the last one here, or you want to try some regression, talk about regression for 40 minutes?
Maybe regression,
Yeah, I agree.
please.
You guys okay? Does anybody want to see Eleanor's top 5 percentile? I'll just draw it, okay? Let me draw this one. That's all you need for that one. So if I draw this one, okay, so if I draw Eleanor's score, so again, it's a backwards problem. So there's always the 2 steps. We begin with the Z. The Z looks like this. And I'm going to get my ruler. Keeps me leveled. All right, so to be in the top 5 percentile, where should I be? Where should my cursor be? This would be the top 50%. This would be like the top 30%. I keep going, right? The top 5% maybe somewhere over here. Remember, I always write 4 decimals for the tables. Okay, so what do I do with that information? Remember, what did we just do? Repeat what we just did. Go inside the table. And what number I'm going to look for inside the table? The table only gives me the area to the left. So what is the area to the left if I want to be at 5% above?
95.
Very good. So this is 95%, or we write 0.9500. So we look inside for 0.9500. What do you find?
$165, 1.65.
Okay, so there's some issues, right? Let's go see. All right, so
0.9595 is like the
uh-huh,
closest one.
uh-huh. All right, so let's look for 9500. We go inside and
94.
9500. I see. Aha. So this is what he's noticing. This
Yeah,
is
between.
0.0005 below, and this one is 0.0005 above. So they're equal distant from the answer of 0.95, or what we're looking for. So what we do when they're exactly the same is we average. What are we averaging? 1.64 and 1.65. So we're going to average that to get 1.645. $1.645. Questions about that? That's those are the rules I outline,
That makes sense.
which makes sense for the best we can do. If you put it in Excel, you get more precision, but this is what we can do with the table. You guys can use either one. Okay, so 1.645. Are we finished? No, we need to transcribe into the variable of the grade. So we're going to use the same rule. Z standard deviations from the mean gives me X. So X is Z 1.645. Standard deviation for Eleanor is 100. Plus the mean is for Eleanor 500, and that is her score. So 164.5 plus 500 is 664.55 anyway. Or you can round to 665 as her score. This is her final. So this is the score she would need to be. Oh, sorry, where am I? In the top 5 percentile. In other words, we call it the 95th percentile. All right, let's so we covered it. There's some other problems here. If you want, you don't have answers, just put it in the there's these ones too. I think I put the answers for page 24 though. You have the page 24 answers, I believe. Page 24. Yeah, at the top. Yeah, at the top I did page 24 and 25. You guys see that? Here?
Yes.
Right. Okay, if there's anything outstanding, just email me or put it in the photo and I can respond. I was slow responding this time. There was a question, I think I answered it. Was it here or it was here, right? Did I answer the photo? I can't remember. Yeah, it was in the third module. Anyway, so you guys can put questions in the photo or email me and I can provide the answer, either make a video or we can meet. Okay? So are we going to pass with normal? You guys are going to try the quiz for the normal today. And then we have the regression material. So regression material is actually very short. It's very short, but that doesn't mean it's easy. It takes a moment to get the hang of it. And the way that I like to review it is to go into the homework. The homework is very revelatory. It's quite good. Did you guys get this far with the homework of regression?
Yeah. Well, at least I did.
You did? It was good, right?
Yeah,
Because
I
it
have like 2 questions, I think.
okay.
Just double checking. The first one, it's in the first question. Because I don't know if like how would I from this plot, I guess like if I'm gonna use linear regression, how do I get it from this visual? Because we have points of data like all over the place. So at first I thought that it wasn't okay, but yeah.
Oh, what was the answer from this plot? The data appear no, the data do not appear to me. What was the answer?
Z.
Y-
So the
See?
plot is okay, yeah. The use of linear regression here is reasonable as it stands, but
Okay.
I didn't understood why.
Yeah, because what um with regression, the idea is about your predictive variable being able to explain the phenomena. So the predict so you want to use a variable that's independent to explain the one that's dependent. So the x is going to explain the y. Whatever it doesn't explain falls into the error or the residual. So what you're supposed to do is get the residual. So residual is, if you guys got this far, the residual, let me see if I can,
Yeah, it's the y observed minus the y predicted. So
yeah, maybe I'll show a slide or something. So it's very short, and I force you to do some line review if you don't know about lines. So this is the data. All the scattered points are the data, and the idea of linear regression is, can we use just a line that we learned about in high school as a replacement for the data? So we can do that, but then there's error, right? Because these are not exactly on the line. So there's several things we have to do. For how do we get the line? And I discuss how we get the line and what it is. We call it the prediction line, or the results of ordinary least squares give us this statistics line. And then we want to talk about how good that line is, and it's as good as the size of the error, and the error is the residual, the observed value, which is the dot, and the predicted value that is straight down here on the line. So that's a big residual there. So what we're doing is, for the values that aren't there, for the observations that aren't there, we're using the line to make prediction. For instance, here, there's no data here. What if I want to know what is the chance of x being a certain value, or if x is a certain value, what will y be? So that's how we use the line, okay? So if the x variable is not good at predicting the y variable, you're going to see it. You're going to see it in the measure of these residuals, this difference from the line. And one measure that captures that is the R. So R is a measure of direction and strength of this linear relationship between the variables. The bigger the R, the closer the R is to 1, or close to -1, means it's a really good fit. If it's closer to 0, it's not a good fit. And one way you can observe, if you see, like in here, there's the data here are the predicted values for every value. Okay, so these are the y's. This is y. So for certain values of x, so all the observations of x, using the line, they calculate the predicted value y, and they plot it against, or they plot the residuals against it. And if there's a pattern here, if there's some sort of pattern or a trend, then it means that you're missing something from trying to explain y with x. You're missing something and anything you're missing falls into the error term or the residuals. So there shouldn't be a pattern. If there's a pattern, it means that it's not a really good model. And this is, I mean, how do you know there's a pattern? There's no pattern. You check here with the 0. So the data is above and below 0, scattered around 0. This is considered an okay pattern. I'm not going to ask you guys about this because I didn't really get this far. So this question, don't worry about it, but I just leave it there to have the discussion of how do you look at this. So if you saw like a clear line going down or a line going up or a curve going clearly, then that would be a pattern. That would mean that your model, the line that you used and the one variable you used predict were not good. You're missing enough that there's a pattern in the residual, so it's not a good regression. And there's nothing here. It talks about normal distribution, but that's yeah, that's not really, we're not going to get into that. So anyway, so the plot is okay. The use of linear regression here is reasonable as it stands. So if you see a pattern, it means that you're missing a variable, and you should probably use a multiple regression instead of a linear regression. So again, don't worry about number 1. So what else?
Thank you.
Were you able to get the others? Or
The other question I have in this particular set, it's for exercise 22, I think. Yeah.
Anybody else have questions about regression, or you didn't get this far? I taught you how to put this in the calculator, right? To get all the results.
Yes.
22. 2 Olympic gymnasts tie on every event, each always getting the exact same score as the other. The actual scores, however, differ from event to event. What is the correlation between the scores of these contestants?
I got confused because it's saying that they have this, like they are tied, but they have different points, like from event to event. So I thought that it was going to be negative because of the difference, but then when I look at the answer, it was positive. So that's where I got confused.
Okay, well, what they're trying to say is in one of the, so, you know, they do the bars and they do the balance beam. Okay, so they have different events. For the bars, maybe they score out of 4 or 8 or 10. And maybe for the balance beam, they score in a different way. Or, so I think they're all out of 10 for the Olympics, aren't they? I can't even remember. Sorry, guys. The Olympics, is it out of 10? 10 points? I'm thinking of when I used to watch
Yes,
it.
it is. It is.
Is
Yeah,
that
it's
so?
10.
Every event is out of 10, but they get the same score. So 2 gymnasts are getting the same score, but let's say they're both getting high 8s on the balance beam, but on the bars they're both very good and they're getting 10s or close to 10. That's what it's saying. So sorry for the confusion.
Okay.
The
now
point
it
is that
makes
the
sense.
numbers they meant to confuse you and trick you, but basically they're different numbers. So they're getting like 10s on one event or one in one event, and but on the other in the other competition they're getting like 8s, or another one they're getting 6s because it's harder, but they're getting the same. That's what it's saying.
Okay, and since they're getting like the same from event to event, that's why we have the correlation being 1, right?
Yes.
Okay.
Yes. So if it has event 1, so the data, let's say the data is event 1, event 2, event 3, event 4. The numbers are all like across are the same. Like they have 6 and the other one has 6 and the other one has 8 and then 8 and then 10 and 10. Does anybody want me to draw that or write that? But that's basically what they're saying. I'll make a, I'll make a, an, I'll make a table for you. All right. I just made a,
Professor,
yeah,
can you explain exercise 16 from that homework?
sure. Let me just show you this.
Okay.
Okay, so that's basically what they're saying. There are several events. Contestant one's grade scores and contestant two score. Maybe there's slight variation, but the way they wrote it, just to be clear. Okay, so that's what you envision. So yeah, always try and write out variables so that you don't understand what they might look like. It might help you. Okay,
Awesome. Thank you.
so question 16.
Yes.
Okay, so yeah, I like these ones. So first step when you see like question number 16 is draw it. So just put your pen down and try and draw that and stare at that. That's the first thing to do there. And then think about if it's 1, what does it have to look like? If the correlation is 1, what should it look like?
Straight line.
A straight line. It should be a straight line going up. Okay, that's how it should be. So draw each one. So I can do it with you. I'm going to draw each one. Otherwise, staring at them it might not be some people can get it staring at it, but not everybody. So sketch it. So it's -1. I'll show you my graph in a moment. I should really use my ruler. Doing my ruler. Okay. Okay, so A, -1 and 3. So X is -1 and Y is 3. Right? And then the next one is X is 0, Y is 4. X is 0, Y is 4. And then X is 1, Y is 5. You see? So what do you say about this one? Is that correlation 1?
I think so.
Yeah, so 1. So the main thing is that R is a measure of strength and direction of a linear relationship between two quantitative variables. So the strength is perfect. It's right on the line. And it's a positive relationship because it's a positive number. Or anyway, it's going in the, as X goes higher, Y goes higher. So that's a positive relationship. Okay, let's try another one. I mean, that's the right answer. It's probably it, but just to show you. So Y -1 and 1. So X1 and Y -1. That will put us here. X2 and Y -2. X3, Y -3. Did I do something wrong? Because this is working out too. X3, Y -3. What's wrong with this one? Is this 1?
Since the slope is negative, then R will also be negative, and it will be -1 instead of 1.
Exactly. Okay. So here R is going to be, it's perfect, but it's perfect. It's a negative relationship. Okay, so you got the idea of it? Draw it. Just draw. The same argument I had before. When you're not sure what you're looking at, write it down, try and explain the variable or draw the relationship. So that's not the answer. Do you want me to do any more? C, D. So if you draw them, you'll see they don't have the pattern. So how do you see it here? As this, so for X, let's go back to the questions. So for every unit that X goes up, Y goes up. That's how you see the pattern. So this is going up 1. This one went up 1. So this one went from 0 to 1. That's 1. This one went up 1. Okay, so that's what's reflecting that it's the trend is positive and perfect. It's always exactly 1. Now it could still have an R of 1 if you went by 2, but you would have to do whatever you're doing, you have to do it consistently. So here it's negative because there's a difference of 1 between them, but this one's going slowly down as this one goes up. So that's a negative relationship. Now, like after you've drawn it, now you can see it, I think. So this is going up 1 each time, but this is going down, deeper down each time. So that's a perfect relationship, but it's opposite. It's a negative relationship. Inverse relationship is another way to say it. Now this one is going up 1 and this one goes down 3. And then it goes up 1 and it goes up 3. So that is not the pattern, right? It has to go steadily the same. All right, so you guys can reason the other ones for yourselves. Is that all right?
Yes, thank you.
Great. What else? That's a good question because you feel like, how the heck do I look at these numbers? I should know this. So just draw it and then it'll speak to you. Which other questions here? How many of you guys got into probability? You can put it in the chat if you got into probability. Try and do probability today because now you're fresh. Hopefully you have time today, tomorrow, just to be fresh to get started. Consider it like last week and then finish up to let me talk about that for a bit. Yeah, because I actually break up probability into module 7, 6, and 7. So I actually give you more time. I'm just reading the chat. Okay. Okay, let's look at okay, unless you have any questions on regression. Like, do you want me to do a problem with residuals or something?
Yes, please.
Okay, which one should we do? Let me see in the okay, and then okay, first let me just say quickly, if I can, about module 6. For module 6 and 7, both are on probability. Okay, so the first module 6 is have everything in module 6 really. But up until let me verify in the notes. So what I did was I split it in two. So for module 6, it's going to focus you, like the review material focuses up until page, the rules. It focuses on the rules until 14. Okay, page 14. So that's module 6. And module 7 is the rest. But all the videos, I put them in 6. Because the review exercises start on 21. So what I'm trying to say to you is don't be discouraged. Like 6 and 7 are the same thing. So when you finish 6, you're going to realize, oh, I'm still studying it in 7. There's no new material in 7. You just go back to 6. Got it? So basically, this is up to page, what did I say, 17?
Fourteen.
Yeah, 14. So this is up to page 14, and then just the rules, focus on the rules, and then really deep into all this other stuff. So make sure you get, while you're fresh and ambitious today, get into it. Okay, let's see if we can do a residual problem. I don't know, something in 5 minutes. Remember, you guys can refer, you can open everything. I don't mind for you, the quiz, just you can't communicate with each other. That's all, right? You guys should just work with the materials, organize yourself, have a study sheet with you that you prepare with examples, formula, whatever it is that you need. Let's look at the English notes and slide or page. So I go step by step through the problems here, and I tell you, you don't have to do anything past page 9. And these are the kinds of questions I ask you. And question 7 is, what is the residual if y is a particular value? So what you're supposed to do is use the line that I give you and the observations. So question 7, what is the residual when x is 59? So the residual would be observed minus predicted, and I explained to remember that like it's in alphabetical order. I could subtract them the other way, but this theory is developed with observed minus predicted. It's in alphabetical order. OP, observed minus predicted. And predicted always has a hat because it's an estimate of the observed value. So this is the X and this is the Y. This is from the data. So you pull that aside. So follow the steps. And what I need, so I have the observed, this one. I need to get this one. How do I get this one? How do I get the Y predicted? I get the line. So I'll give you the line, and then you put in the line the X value, 59, and you find the predicted, and then you subtract. Okay, so use these as a guide. The 7 questions, or sorry, I have 9 questions that you need for regression. This is the shortest one, and because if you did study this and you learned how to use the calculator, it's going to make your life easier. What I will do next week is I will put, so I mean this week is going to be normal, regression, and probability. If you want to skip the probability questions, that's fine because I'm going to make it out of 4. Next week I can make it with regression again, so you have a chance to do the regression problems if you didn't even get that far. Okay, so I'll put regression and probability. That's all it will be next week. Okay, so this way we just keep building our knowledge, and you don't feel defeated that you didn't have enough time to get through stuff. And we're going to catch up. Next week is the 10th, so you should have finished module 6 by next week, and then you still have, see, this is also probability. So really till the 17th of May, so 2 more weeks, you have to work with probability. So you guys are good. You guys are in good time. All right, you're going to be okay. And I will put some questions from regression on there in case, just to, you know, help you study or incentivize you to keep studying and not give up on regression. All right, so are we good? You want to ask me something else? Did I go too fast?
I have a question, but it's more for me to prepare mentally if it's needed. I
Yeah.
know that you posted 2 different midterm exams reviews that we needed to use, like, to move forward throughout the semester. And I just want to make sure that if there's a midterm, we know when it's happening, because it's
No, there's
not.
no midterm. It's just going to
Okay,
be the final.
perfect.
No, it's just these tests, these little tests.
Okay, perfect. Sounds good. I just got
It's just
confused
because
for a second.
I changed the format just this semester or trimester. Because
Okay,
I think this is better, that you get little tests all along and that it adds up and you feel
yeah.
like you're not waiting for the
Yeah, I
test.
like that. Thank you.
Yeah.
I just
Ooh.
wanted to make sure.
So what
Thank
we're
you
gonna
very
do
much.
is we're gonna get out, and you guys, the test should open, and I'm gonna open Zoom again, okay? So I can record you writing. So I'm gonna stop, and I'm gonna stop the recording and then start the recording again. Or I have to get out. You guys can stay there, but I gotta get out.